I got this. Okay, chapter 2.1. We're going to use inductive reasoning to make conjectures. Here are the objectives. By the end of the video, you should be able to use inductive reasoning to identify patterns and make conjectures, and then also find counterexamples to disprove conjectures. So there's 3 different parts. The first part is going to be what is inductive reasoning. Here's the whole fancy schmancy spiel about inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. Some keywords to identify with inductive reasoning is you use observations and you use patterns to determine if something is true or not. So for example, if I give you this list of numbers, 7, 14, 21, 28, without even thinking, some of you guys are going to be like, well, the next one's 35, and then it's going to be 42, and then it's going to be 48. Wait, no, 49, excuse me. Because then you notice that each one of them is going up by 7, or that these are multiples of 7. Looking at this list of the triangle, if you notice, it's being turned to the left each time. So the next triangle would look like this, and then it would go back to looking like this. So these are inductive reasonings, and you're using inductive reasoning because you notice the patterns. Now, when you make a conclusion, that's called a conjecture. A conjecture is a statement you believe to be true. I would definitely write this down. I use this word a lot. So for 3 and 4, I'm asking you to complete the conjectures. So complete the statement. The sum of 2 positive numbers is blank. So to figure out what the blank is, you're going to try different numbers. Try easy numbers. Try fractions. Try negative numbers, try zeros. These are all good things that you should try to use. This helps with that SAT prep too. So the sum of 2 positive numbers. Positive means they have to be not negative. So for example, 2 plus 2. Okay, well that's 4. Let's see, that's I would consider an easy one. Okay, what about a fraction? 1/2 plus 1/2. Okay, that's 1. Well, we can't be negative because they said it's positive. Zeros. Okay, what about 3 plus 0? Okay, that's 3. So what's something that's similar about all of these answers? Some of you guys might say, well, they're always whole numbers. Well, what happens if I did 1/3 plus 1/2? Would that be a whole number too? Nope. So we can't say that they're always going to be whole. Can we say that they're always going to be even? Nope, because these ones are odd. So we can't say whole or not whole. We can't say even or odd. So that our answer, there's something that's common with all these answers, is that they're always positive. So our conjecture is the sum of 2 positive numbers is that the answer is always going to be positive. Go ahead and try number 4. Last thing we're going to talk about is our counterexamples. So if you wanted to prove a conjecture is false, you will only have to find one example in which the conjecture is not true. So you can use a drawing, it could be a statement, it could be a number, it could be an example. So when I say counterexample, that means prove it false. Prove it wrong. So last thing, determine if each conjecture is true. Remember, conjecture is a statement you believe to be true. If it's false, give a counterexample. So here's something that Mr. Joe says. Mr. Joe comes in and says, if you're an athlete, then you are on the football team. Well, do we think that's true? Some of you people are going, no, it's false because I'm an athlete and I'm on the volleyball team. So it's false, and you can give an example. For example, Olivia is an athlete and she's on volleyball, not football. So that was kind of an obvious one. Go ahead and try number 6. 2 supplementary angles are not congruent. Think about whether or not you think this is true or false. If it's true, cool. If it's false, give me a counterexample. Counterexample. All right, so we talked about inductive reasoning, counterexamples, and conjecture. Those are 3 vocabulary words you should have written down in your notes.